All right, yesterday we talked about these particular functions. I believe we got as far, I don't know, maybe one of the, I can't remember. Let's just go back over them real quick because I'm about to have you do an activity where you match the name of the function to the graph. So let's go back over these really quickly. Yesterday we said this one was in slope-intercept form. It is a straight line. The only kind of line that you cannot write in slope-intercept form is what? What kind of line can you not write in slope-intercept form? It breaks all the rules. It's the rebel, the vertical line. We can't write because it doesn't have a y, does it? You can't say y equals. You guys remember what the equation of a vertical line is? Remember our aerobics?
Y equals X equals whatever.
A number, right? X equals a number, like 2. Okay. And so I could not write that in slope-intercept form. So it would be it's not a function, right? Doesn't have a slope. Do you remember that about vertical lines, all those things? Then this is a step function. We talked yesterday about the greatest integer and how it forms little steps, but how it has a colored in circle and an open circle, so it would pass the vertical line test because when I drew a vertical line down through the hole and the colored in circle, it would hit the colored in circle, which is a point, but the hole's not a point, is it? It's just a hole in the graph. And then we know about the absolute value graph. We know about the quadratic graph because this graph is called a what? A P word? Parabola. It's called a parabola. Good. And then we've talked about the cubic function that looks more like this, we said. But this one's got a little bit more of a curve. X intercepts here, here, and here instead of just one at the origin. And then we talked about the square root function before. Remember, we would do like the broken arm to talk about. That's what that looked like. And then I think I was talking about an asymptote yesterday, which is a line that a curve approaches but doesn't touch, and how this curve, this exponential graph, is approaching the x-axis, but will it ever cross it, touch it? No, it will not. It's like an electric fence. But where is this part of the graph going?
Forever.
To positive, what do you call
to
forever?
Infinity and beyond.
To infinity, like Buzz Lightyear. We're going to positive infinity. All right. So, with that in mind, I'm going to draw names, and all you have to do is pick up the word and connect it to whatever graph that it goes to. Okay? So instead of calling out those names, I'm just going to hold them up, okay? Hold them up. All right, so you can do any one that you want to. Pick any word, lay it on any graph. All right, so let's go with you first.
So I can choose any one that I want to?
You sure can.
Okay, that's... Do I
Put it right on the graph.
Oh, okay.
Oh, she did the one I was going to do.
Very good. For some reason, that's a chicken sound. I'm going to owe you a buck, yes. All right, and so then the next person, you can do whichever one you want to.
Do the next one.
And you do a cow sound for some odd reason. Okay, very good. And then the next person, job.
She didn't see it. Keep going.
Oh, very cool. That's cool sound. Fanfare. All right, and then who is next? Who is next?
Okay.
Right. Here we go.
Can I talk now?
You may talk.
Okay, good. I'm pretty sure linear, the easiest one I thought.
Very good. And how appropriate that you would have an explosion. Very good. All right, and
Yeah,
then
just the rocket launching.
the rocket launching, and then the next person. Very good. The drum roll. A very long drum roll. And then the next person.
It's a 50-50 chance you got. Yeah, I'm pretty sure it's this one.
Very, very good.
Drum solo.
That's symbols, yes.
The drum, and then you had the singing.
All right, so I have no more names to draw. I have to put everybody back in. So let me ask you, do you remember what quadratic looks like? What does quadratic mean? X is 2. Good. That's what the graph looks like. And X is to the what power?
Oh, there's no one on there.
Second power. X is squared. It's quadratic. And what do you call that graph? We just talked about it.
A
in there.
parabola.
A parabola. Very, very good. Okay. All right. Now, what form is this equation in? 3x minus 2y equals 12.
Standard.
Good. It is in standard form. All right. What I have here is some partial solutions to that linear equation. For example, in the A, I have x and I need to find y. I'm going to do that one with you, and then I'm going to let you do the other 3 for dollars, okay? And so here we go. Let's do 2y. So where would I plug in the 2? Where does it belong? In for what? X. Why? Why do I plug it in for x?
Because it's the X.
It is for x, right. So I'll do 3 times 2 minus 2y is equal to 12. And we can solve that. 3 times 2 is 6. Now I've got to solve for y. What would I do first? Do what on both sides?
Subtract 6.
Good job. Subtract 6 from both sides. And then, what would I do, guys?
Divide.
Both sides. Divide by -2. And what is y equal to?
-3.
Perfect. And so the solution here is 2, -3. 2, -3 is a solution to our linear equation written in standard form, just like you said. It is also a point on the graph. If I graph, do you guys remember how to do -a over b and c over a and c over b to find the graph of this line? Another point would be this solution here to -3. Okay? Any questions about that at all? Just do it anywhere you want to, okay? Okay, see how this was negative here? Bring it down here, here, here. So that would change that. Okay, so what would our ordered pattern be? It would be -2, right, so that would be. Very good. You guys agree with that answer? Yeah. Scroll down one, two. That's perfect. Very good. You guys agree? Anybody have a question? You guys seem to remember a lot of things about functions. That's good. Very good job. Right, does anybody have a question about that?
I got all real numbers.
Did you?
Yes. Because
Did you not have a variable left?
Very.
Did you have an x left?
Yes, and a 3.
All real numbers only occurs when you end up with a reflexive property like 0 equals 0 or 6 equals 6. There's no variable left, okay? So you had 0 divided by 3 and you just wrote all real numbers?
Because I thought that you could divide 0 by 3.
You can divide 0 by anything, you can't divide anything by 0. Remember, 0 can't be in the denominator. Alright, so good question there. Alright, so remember, the point of this whole thing is that you know that these ordered pairs are solutions to this equation, but also, if I graph that, remember we said with negative a over b, c over a, c over b, the slope, the x-intercept, the y-intercept, that line would also pass through those points. What's special about 0, negative 6? Where would that be? That would be the what?
Second quadrant.
Go across 0 and go down 6.
Oh.
Where would that be? On the y-axis. What do you call a point on the y-axis?
The y-intercept.
The y-intercept. All right, let's look. What if I did c over b? 12 divided by would I have gotten that negative 6 for my y-intercept? I would have, wouldn't I? Do you guys remember finding the slope and the x and y-intercepts before?
Sort of.
I got good news. We're going to do it again. I know y'all be so excited about that. All right, so we're going to do some of these that we've done yesterday and today. We're going to do them for a grade. So just to review, we know the definition of a function. We know domain and range. Domain is the set of what? The set of x's. And the range is a set of
Y values.
y values. All right, and then what if I give you a set and ask you to write it as a mapping? Can you do that? Because these are mappings. Remember we talked specifically about the one-to-one function. How do you know, what does one-to-one mean? Without reading them.
One going to it and one coming from it.
Yes, one coming from it, one going to it, exactly. And that is a special type of function, one-to-one function. Now, a function does not have to be unique in its y value, but it does have to be unique in its x value. And I can have more than one arrow coming to a number, but looking at all the x's, I can only have one arrow coming from them. And so this one's not a function because of the negative 3. Remember that? Okay, so there are some problems where I gave you a set and asked you to write them as a mapping and then to tell whether or not they're functions. Then there's some more problems where I give you a set and ask you to graph them and use the vertical line test to determine if they are functions. All right, how do you know by using the vertical line test if you have a function?
It's
it
not
only-
a function if it hits one point.
Yes, if it hits one point, you were going to say it is a function, but if it hits more than one point, it's not. That's exactly what you do. All right, and then there are some that you have to make a table and you just substitute in like we were doing right here. It gives you like a couple of different x values and you substitute in and you just make a table with your answers. There's some graphs where you use a vertical line test and tell if they're functions. We're not going to do one yet where you have to determine what kind of function it is. And then there are several of these problems where you identify either the x or the y. Given one, find the other, okay? All right, so we need clean paper, pencil, and calculator.